Welcome to the second section of this TensorFlow Deep Learning Recipes course. In this section, we talk about supervised learning with deep neural networks using the TensorFlow Core API. Let's take a look at what we are going to do in this section. In the first video, we are going to build a deep neural network for a regression task. We are going to be predicting the diamond prices in this example. In the second video, we will build a DNN model for a classification task, and in that case we are going to be building a model using a dataset that comes from the Higgs boson research. In the third video, we talk about how to perform regularization. Regularization is very important in DNN models because they have thousands or even millions of parameters, so they tend to overfit the data. So regularization is very important if you want to apply these models successfully. And finally, we will talk about how to work with optimizers in TensorFlow Core. This API makes it really easy to change and to try different optimizers with your different models. Okay, so this is the plan for this section. Let's get started. This is the first video of this section, and here we are going to be building a deep neural network for a regression task using TensorFlow Core. This is the plan for this video. First, we will take a look at the diamonds dataset. Then we will explain the code, and finally we will review the recipe that we will give in the code for building a regression model using TensorFlow Core. Now, before starting taking a look at the code, let me tell you that section 1 of this course was recorded using TensorFlow version 1.3. A few weeks later, during production of section 2, version 1.4 was released. So the rest of the course, I just wanted to let you know that the rest of the course will be done using TensorFlow version 1.4. Okay, so this is the dataset that we will use in this example, in this video. This is the diamonds dataset. We have here prices and characteristics of about 54,000 diamonds. So we have some numerical variables like the weight of the diamond, which is here called the carat. We have some categorical variables like cut, color, or clarity. We have other numerical features that have to do with the dimension of the diamond. So the goal here is to predict the price of the diamonds. So we will use all these features, all these variables from the diamonds dataset to predict the price. That is the goal of this example. Okay, so now let's go to the code, to the Jupyter notebook, to see how to build one deep neural network to predict the price with this dataset. Here we are in the notebook where we have the recipe for developing this model. Okay, so let's go through the recipe and through all these steps. Step number 1 is to load and prepare the data. This is a relatively small data set, so I have the data here in a CSV file, and I used this read CSV function to load the data into the program. And then I used the train test split function from scikit-learn to divide the dataset into training and validation datasets. Okay, now step 2 is to build the input pipeline. We're using here a batch size of 128. Now, as we discussed in the previous section, getting data into TensorFlow is not that easy, but we can use this dataset API that we talked about before to build the input pipeline for these models. So we create here the dataset, then we shuffle the dataset, we divide the dataset into batches in this line, and then we create the iterator object, and this iterator will allow us to iterate through the entire dataset in each batch. Okay, and this next element node in the computational graph will give us the next batch and the next batch and the next batch each time we update our optimization operation. Okay, so this is step 2. Step 3 is to build a function containing the deep neural network, and this is optional, but it is recommended. It will be better if you have your model inside one function so you can call it very easily. In this case, we are building a model with 4 hidden layers. And we are using for each layer this function from TensorFlow.layers. We are using the dense. This will build a dense, densely connected layer. We pass what are the inputs for the layer, what number of neurons we want in the layer, the activation function. We are explicitly saying that we want the ReLU activation function in this case, and the kernel initializer is the weight initializer, but here it is called the kernel initializer, and we are using here the Xavier initializer. This is an initializer that has been shown in the literature that works very well. It prevents some of the problems related with training neural networks. So we are building 4 hidden layers in a similar way. The only thing that is different is that, of course, we are passing to each layer as input the previous one, and we are changing the number of neurons per each layer according to this schema that you see here. Okay, and finally, since this is a regression task, what we are doing is predicting just one output. So for each diamond, we want just one price, and that's why the number of outputs here is 1. Now, we are using this quiz function here to output just a rank 1 tensor, or you can view this as a vector. We want to pass a matrix of inputs, and what we want back is a vector of prices. So we pass here a 2-dimensional matrix that contains the samples and the features, and then what we will get back is the respective prices for each of the samples we pass here. Okay, so this was step 3. Now step number 4 is to create the placeholders to pass values for training and evaluation. And here, as you know, we need 2 placeholders, one for the X values, for the values of the features, and we pass here the shape as none, because this is the number of samples that we will pass. Always the first dimension in the X matrix is the number of samples, and this placeholder is to pass, the target or the real values for the prices of the diamonds in this case. Now, step number 5 is to define the loss function. Since this is a regression task, the most commonly used metric for a regression task or for a regression loss is the mean squared error, and we pass the predictions that we get from our function, and we pass them here in this function that comes from tf.losses. We pass the true labels, or the true target or labels, however you want to call it, and the predictions that we get from our neural network. Now, the lines that you see here, these lines are optional, and these lines are just to write some values to later visualize in TensorBoard, and I will show these values to you in a moment, and you can explore these at your own pace. Okay. Step number 6 is to define the optimizer and training operation. Now, in this section, I am using the Adam optimizer because it has been shown in the literature that it works really well for a great variety of problems, and it has some hyperparameters to tune. Now, I am not trying to tune these hyperparameters here. I am using just the defaults, and I think they work well. Okay, so I am using here the Adam optimizer. And then the training operation is to tell the optimizer to minimize our loss function, which in this case is the mean squared error. Now, step number 7 is actually optional, but I think it is better if you write a function for running the training operation. So for each epoch, this function will be executed. This is not necessary, but your code will be more organized in this way. Well, this is just an advice. Okay, so in this function, we initialize our iterator object. So we start with the whole training dataset, and then we get the X values and the Y values, and we pass these values to the training operation here. And here we just write some summaries to visualize in TensorBoard. Okay. Step number 8 is to run the computational graph. The first thing here is to decide for how many epochs you are going to train your model. And then inside the session, we create a session. We initialize all the global variables. In this case, I am just adding the computational graph to be able to visualize this in the tensor board. And then for every epoch, I run the train model function that I wrote in the previous step. So as you can see here, this simplifies the code. Then I just close the writers, and then I get the predictions just to visualize the predictions. And then the final step is to visualize or analyze the results of your model. In this case, I am just plotting the predicted prices versus the observed prices, and as you can see here, they are pretty close, the observed prices with the predicted prices, so they fall in this line, so they are very similar. And if you do some more analysis, some more statistical analysis or visualizations, you can see here that most of the predictions are with $500, so they are actually pretty close to the real prices. Okay, now the model has been trained, and here we are in TensorFlow. I just wanted to show you very quickly the learning process, and you can see here the training and the validation root mean squared error. So this is just the square root of the loss function that we used, and as you can see, you know, the network learns pretty fast. After the 50 epochs, most of the learning has been done, and then it is slowly, you know, it keeps learning, but at a very slow rate. And here the learning kind of stops. So I think 300 epochs was okay. You can run it for a little bit more if you want to experiment with this. Okay, here you can see the computational graph that was used in this TensorFlow program. You can analyze each of the node to get a better idea of what's going on with your program. And we actually can visualize some distributions. For example, this is the distribution of the errors. So this is the actual values minus the predicted values for the network, and we can take a look at the histograms, the history of the histograms of the errors. Okay, so you see here that the errors are getting, the histogram or the distribution of errors are getting closer and closer to zero as we train the network for more and more epochs. So this is the visualization that you can take a look to at your own when you run this program in your own computer. Okay, so now let's go to the presentation and review the recipe that we followed in this video. Okay, just to summarize, this is the recipe for building DNN models for regression tasks with TensorFlow Core. The first step is to load and prepare the data. Second step, build the input pipeline. Third step, build a function containing the deep neural network. Fourth step, create placeholders to pass values for training and evaluation. Fifth step is to define the loss, and if you are doing regression tasks, most of the time it will be the mean squared error, the loss that you will use. Step 6 is to define the optimizer and training operation. Step 7 is optional, but I recommended to write the function for running the training operation for each epoch. And step number 8 is to run the computational graph, and then the final step is to visualize and analyze the results of the model. So if you follow this recipe, you will be able to solve almost any regression problem using a TensorFlow Core. Okay, so in this video, we provided a recipe for building a deep neural network model for a regression task.